Hi everyone, my name is Jake Baffa.
I'm Nathan Burris.
I'm Brett Peterson.
I'm Gabriel Rusura.
And I'm Damon Zerker, and we are IE441 Team 3, and this spring 22 semester we're working with Rada Manufacturing in Waverly, Iowa.
The reason we were hired by Rada is that business is growing and they currently cannot fulfill their demand to its entirety. This is why they are implementing 2 new automated cells aimed at increasing production capacity. However, they have some obstacles to overcome in order to free up floor space for this to happen. Most notably, figuring out material flow throughout the facility and decreasing their excess WIP. This is where our work with Rada is focused on.
The team established 3 main objectives. The first objective was to determine a way to clear up floor space so that space is created for the new automated cells. The second objective, that builds off the first one, was to create an implementation plan for the new cells that doesn't disrupt current production. And the third objective was to validate that the automated cells can produce at a cycle time of 44 seconds per part.
The first step in our project was to create a current state analysis. For this, we had 2 main objectives. The first being creating an AutoCAD layout by hand measuring all machines and features of the facility. From this AutoCAD layout, we were able to create Sankey diagrams from process flows of various products by utilizing the Flow Planner software. These diagrams enabled us to understand the flow of material through the facility, as well as identify high-density areas of product flow.
Our team also spent time value stream mapping Rada's facility. Value stream mapping is a great way for consultants to familiarize themselves with a new facility and understand the processes on a deeper level. It also reveals surprising trends and tendencies of the facility and its management. In Rada's case, their inventory moves in waves throughout the facility, as is shown by this bar graph. Wave inventory means that there must be enough space for large amounts of WIP everywhere in the facility, which is a big issue when we are trying to find extra floor space for the automated cells.
When it came down to our final design, the 2 biggest decisions we had to determine were location and orientation of the automated cells. We determined that the machines would be best located where the riveting station currently is because there's minimal traffic with their current product's process flow and minimal amount of machinery necessary in order to move to make space for the new cells. Another benefit to this location is that we will only need to purchase 1 additional dust collector, and there is already available space in the collection house just south of the Claire's machine. We determined that the orientation of the 2 machines would be best suited to face each other because this will allow for efficient material handling from the operator and will allow for easy access to load and unload material, as well as give forklift access on the pathway in order to move the pallets of knives.
The installation of the 2 new automated cells will increase production capacity by more than 1,300 knives per day, or 327,000 knives per year. This is a 9% increase in paring knife production and a 2% increase in overall production. The estimated total cost of the project, including both machines and 1 dust collector, lands at $526,000. The assumption given to us by the company comptroller was that all excessive knives produced would be sold, as Rada has been having trouble meeting demand anyway. If this holds true, we can expect a return on investment of 285% with a break-even point of 4 months.
This project not only will help Rada in the near future, but it will also be crucial in hitting their long-term goals. This is because Rada is using these new automated cells as somewhat of a trial run into moving towards a more automation-heavy expansion in the future.
Our group would like to thank the entire team at Rada Manufacturing, Dr. Sly, and the entire IMSE department for making this project possible.